Alright, we're live! We are going to do some advanced U-Substitution today. We're going to do a little bit more advanced version of this, because I'm going to break some of the rules that I talked about earlier. The rules were meant to get you to where you can see the patterns of U-Sub, but not necessarily always that way that they work.
You never reviewed it.
This is what today is, you goob. U-Sub. What two, well not two, actually three. When do I use U-Sub?
When there's a
Yeah, most of the time when I have a composite function, composite, stuff inside there, which my algebra kids are going to learn about tomorrow. And the other time I like using U-Sub is if I have multiplication or division. Now this one gets that little asterisk because it's not always, right? It's not like, okay, I see multiplication, boom, U-Sub. I see division, boom, U-Sub. You have to think about it. Again, there's no rule that says, if this, then this. You have to sort of see a pattern and see what's going on through there. So, let's amuse Jacob for a little bit. Let's do a normal U-Sub one. Start off fairly easy, and we'll start getting in some weirder ones. Example number 1. Let's go integral. Don't ask that.
Wonderful.
6x e negative 2x squared dx. Because. Alright. To the. Hit him, Fergie. Thank you for. Right. Oh. Great. Solid. To the negative 2x squared. Alright, I have a composite function and I have some multiplication going on in there. What do you think we want to try in U-subbing?
U-Sub the negative 2x squared.
Yeah. With U-Sub, sometimes you might run into something where you really don't know what to do. Just try something. Try U-subbing one step and see if it will cancel out or anything. In my mind, here's the composite part. I'm going to try U-subbing that. So I have U is equal to negative 2x squared du. Remember, taking the derivative, this part would be negative 4x times the differential dx. So therefore, if I move this negative 4 over, it will be du over negative 4x is equal to dx. And again, this is the pattern I wanted you to be able to somewhat notice. I have an x squared component up here, and I have an x component right here. They are related to each other, meaning that when I take the derivative of one of them, I'm going to get part of the other one. And the reason I did all this is because, great, everything's awesome. I should be able to cancel some stuff out. 6x times e to the now u times du over negative 4x. And there we go. That's why my life is really good now, because I have an x on bottom and x on top that cancels. Right. The 6 and the divide by negative 4, those are all coefficients. Where can I put them? Throw it up front. I can reduce that 6 over 4 as what? Yep, negative 3 over 2. Integral of e to the u du, and we have now simplified something that looked pretty chaotic and pretty nasty into a very easy integral. I've trimmed the fat. It's like a steak. You're getting rid of all of the fat pieces, or piece of chicken, getting rid of all of it. Now we have to get rid of it. Yeah, I guess in a steak you sort of want your marbling, so maybe we don't trim all of it. Integral of e to the u is what? Alright, just e to the u. So this is negative 3/2 e to the u plus c. I replace my u. So this is negative 3/2 e to the negative 2x squared plus c. So it's a pretty stock and straightforward U-sub one. Now, good question, Jacob. How would I solve for C? I would need a specific point. I would need to have a point. I would need to say, well, there's a point that is 0, 2. There was something like that. That's how I would solve for C. Keep in mind, if this had been a definite integral, if I had bounds on this, I wouldn't be done yet. I would then apply my first fundamental theorem, do f of b, bless you, minus f of a, and there wouldn't be a c in there, right? We've done the first fundamental theorem in this way. We just haven't really combined the first fundamental theorem with some U-sub. U-sub is just a way to evaluate that integral. Then you can apply your first fundamental theorem at the end and do f of b minus f of a. Dig? All right. We will see one of those. I'll show you one of those here in just a little bit. Let's start getting into something that might be a little bit weirder. Let's go. Imagine naming your kid what? Right, there's a couple of really famous Leonardos. Imagine you're naming kid Jacob. I'm in the Bible. Alright, here we go. Integral 4 over x times 1 plus ln of x cubed dx. Yes. Now, this one is weird. It's a cube. This one is weird because of this boy right here. We have yet to encounter this when it comes to U-sub. Now, luckily for us, most of the time, this will happen very nicely when it comes to these natural logs. If we were just tackling this as normal, I see some composite function in there. What's the inside of the composite function? 1 plus ln of x. So let me just blindly go where we have been going before. Let me replace the composite function. So let me say that u is equal to 1 plus ln of x. Again, right now I'm not explaining it. I'm just saying the composite function, blindly let's plug something in and see what happens. Du would therefore be derivative of 1 is 0, derivative of natural log 1 over x times the differential component dx. So if I rearrange this, 1 over x, if I want to move it to the opposite side, I would need to multiply by x. So this is x times du is equal to dx. So I have the integral, there you go, 4 over x times u to the third times x times du. And this is what I was saying works pretty nicely. Anytime you have natural logs, you're not looking for anything other than a component of x. And sometimes you might need to manipulate this a little bit. You might need to take a 1 over natural log, cube, square, whatever, so that it will cancel out. In this case, it worked out fairly nicely. Our x's will cancel. Wish all of my x's would cancel.
Oh.
That was a total dad joke. 100% dad joke. Integral. It's not funny. The 4 is a constant, so it can go out front. So integral of u cubed. I'm doing my reverse power rule, therefore I'm doing what to that power? I'm adding 1. So it's 4 times u to the 4th over 4 plus c.
Hey, why didn't you move forward to the 4's cancel?
The 4's cancel.
No, not those.
Why didn't you move 4 to the front?
Yes, those 4s.
Cancel the X.
I did move the 4 to the front. I just left it there. I did. Then I plug my U back in. So, everyone with that? Yes, no, maybe so? Cool? Alright, let me throw one at you that I want you to try on your own. And it's going to look gross. Integral of 2 e to the tangent power plus 5 all divided by cosine squared x dx. I'm going to give you a decent amount to try this. See what you can come up with.
My dog ate mine, so I made it I'm so sorry. I'm so sorry.
Place tangent x on
Oh, wait, I'm replacing x.
So, Alex, 1 over 2 is
Right?
This is both.
I'm gonna say because it's like up.
Dingus!
Can't relate. Oh, see, I'll just shoot
Sine over cosine. What's the sine over cosine?
I'll need your. I have a question.
Actually, practically don't.
No, you guys do it. I don't think it would be fine. My foot is stuck in your back.
You made one small mistake. Most of your process is where'd that 5
Yes, and then we would multiply this. I feel like this is dividing. This
Where'd the 5 go?
I don't know. Oh, my
Wait, if you do the anti-root, if you do the anti-root,
Is right.
Hey, there's no secant squared
oh, but if it's e to u, then it's
This is my time to shine. I pray you.
1 over cosine squared, right? It's du all the 1 over cosine squared typically, right? So you multiply by cosine squared. Cosine squared.
Am I done?
Am I getting closer or further away? So I'm up to here. And then you do the next. That's a good point.
Mr. Vistra. Oh, okay.
Alright. Here's the first stumbling block many of you ran into. Integral of this 2e to the u plus 5 over cosine squared x du over secant squared x. And some of you got stuck there. Now, there's something in there that sort of looks like it wants to cancel, but it's not doing it right now. I have something squared and something squared. Is there a relationship between cosine and secant?
Secant squared is actually 1 over.
Secant is 1 over cosine. So I could rewrite that as
Cosine squared.
1 over cosine squared. And when I flip this, this is du. So divided by 1 over cosine squared, it'll go to the top. These actually cancel. Now, this is something I can integrate. Here is the biggest stumbling block that you came up to, and some of you are like, what's wrong? What's the integral of e to the u?
E to the U.
E to the u times the 2. So 2 e to the u. What's the integral of 5?
God dang it!
5u.
What do you think terms of U?
We're integrating in terms of u, not x. So, it's du, it's not dx. So then when I replace my u's, I have a 2e to the tangent of x plus 5 tangent plus c. Many of you just told me, great, it's 5x. That's not true. You need to have that tangent right there because it's a u. Cool? Remember, you don't replace until the end. Integrate with respect to u, get all your u's in there. Then at the end, go back and replace some u's with whatever you took out at the beginning. No, so the 2 is only with this part right here. If this had been a 10, yeah, you could have pulled that 2 all the way out. But this, you can't pull it out of that flag as well. Alright, turn and tell your neighbor, there we go, a funny joke. 3, 2, 1, go.
Get it?
Did you hear her joke?
I did.
It was good.
So disgusting.
What do you call a cow with no legs? Jacob, let's go over this, realizing that I hold your future in my hand. I said, what do you call a cow with no legs? And you said, my mother. You said your to me. Go!
How could you be talking to anyone else?
Alright. All on recording. The punchline is ground beef. We're going to go into definite land.
I don't deserve it.
That is a 4. Thank you, Trinity. Very cool. Alright. So, I have this weird function, and we're doing a definite integral now. Alright, there's a couple weird things I want to talk about this, and this is, I pretty much threw every single thing you hate into one problem. So I can talk about all the parts in this problem. First one, I need a U-sub. I see a natural log. The derivative of natural log is 1 over x. Do I see another x somewhere floating in there?
Yes.
Yes, I'm hoping through some manipulation that those x's will cancel. So my u is going to be natural log. Therefore, my du is going to be 1 over x dx. So x times du is equal to dx. That's what we got so far. So I'm going to plug those in. Now, here's a quick note. What am I integrating with respect to right now? X. Everything is in terms of x, meaning that these bounds are in terms of what as well? X. I'm about to transition into in terms of what? U. Now we haven't done this because we haven't run into it, but technically I need to remind myself that these are x values. The way I do that is I do x is equal to e, x is equal to e to the 4th. Now, in all honesty, if you left that step out, you wouldn't get any points off. You just might confuse yourself. These are x values. I'm going to in terms of u. So this is 5 up top, which I really could pull out front if I wanted to. X times the square root of u times x du. And this worked out pretty nicely. My x's will cancel. There you go. And Leo is finding the thing that most of the time we don't like dealing with. Pretty much 99.8% of the time you are dealing with a square root function. You will always with 99.8% attached to it, need to convert it into some sort of exponential function and move it around. So how would I turn this square root u on the bottom into an exponent without a fraction? Right. So the 5 is going to go up front. The integral, I'm going to drop the x's for just a second. E to the 4th of u to the negative 1/2 power du. Again, that's something that we, for some reason, always like to forget, even though we always need to do it in this case. Anytime I have a square root, 99.8% of the time it's going to be a negative exponent or an exponent so that we can use our reverse power rule. All right, our reverse power rule says we're going to add 1, so this is going to be a 5 up front, times, I'm going to add 1 to this, so this is u to the 1/2 divided by 1/2. I can clean that up a little bit. This is going to be, divide by half is the same thing as what?
Multiplied by 2.
Multiplied by 2, so this is 10 square root. I'm going to replace my u now, which is natural log of x. We also haven't seen this notation in a while. Remember, I'm integrating, and I have definite bounds. So I'm going to put a little line that says, great, I'm integrating from that point to this point. That says I've integrated it. I have yet to evaluate it. I've yet to apply the first fundamental theorem to it. Just so that there's not two things floating around in space.
But that's just...
We replaced the u, Jacob. Now, a quick note. If I really wanted to, I don't do this because I think it's a little bit more simple just to have a pattern that you follow over and over and over again. If I wanted to, I could have converted these x values to u values if I wanted to. How would I convert e to the 4th and e into values of u?
Into the equation we had.
Right, just plug it into this equation. I could have said u is equal to ln of e, and u was equal to ln e of 4. So I could have converted it, and I wouldn't have had to put my x back in. I could have stayed in terms of u, because I converted the only two x values I had into terms of u. I could have done that if I wanted to. I don't want to. I'm just going to follow the pattern, put x back in, and keep dealing with my x's. Cool? So first fundamental theorem says I have to do f of b minus f of a. So this is going to be 10 square root ln of e to the 4th minus 10 square root ln of e. You could, if this was not a free response, the answer is 10 on this answer, you would never see this as an answer choice. You would see 10. I have ln of something raised to an exponential power. What can I do to rearrange that? Move it to the front. For those of you that have forgotten from pre-cal and from the beginning of the year, if I have ln of x raised to the a, I can rewrite that by putting that exponent out front and ln of whatever was there. That's one of my exponent rules, or my log rules. So this is really 10 square root 4 ln of e minus 10 square root ln of e. Natural log of e is what? 1. Did you say 1?
Yeah.
I said y.
I wasn't sure.
So 10 square root 4 minus 10 square root of 1 is just 1. Square root 4 is 2. 2 times 10 is 20. 20 minus 10 is all of that. Yeah, if this was a free response, you could have stopped right here. That is you plugging in your values. You've evaluated the last calculus bit of that, the first fundamental theorem, and you could stop there. But you will likely not see something like this on the free response. You'll likely see this in a multiple choice question, where the answer would just be a singular digit number. You need to be able to simplify it. I want to stop you there. Questions, comments, concerns. There's a lot of little algebra in this one, like a ton. The use of your exponents, your use of the bounds, your use of natural logs, your use of log properties, and then on top of that, it's a big full-blown U-sub problem. It's a very, very good test question. Very good.
Is that like a hit?
No, I'm just saying there's a lot of topics in there that I really like in one problem. All right, we're going back under. Here we go. Yeah, that joke was terrible.
No, but it was reversed.
Yeah, you could say that joke was an inverse.
No. It's not actually.
No.
That wasn't even.
We're learning about inverses in algebra, okay? He switched the punchline with the setup. Switch X's and Y's. I have quality content. Shut up.
So you say.
Laugh at me!
You should go tell another math teacher.
No. Because I have to set it all up and just think I'm funny. Alright. Here is one that I put something like this on the homework to sort of separate who was going beyond, above and beyond, and who was just looking at solutions from there. So we'll see what happens with that. But here is a problem like it. Alright. I have a U-sub, maybe. I think. I don't know.
Yeah, do it.
I see division and I see some composite function. Again, if I can, I'm going to try and use U-sub for any composite something I see. What's the inside of the composite function that I see? X plus 1. So let's start there. Right. And Macy is seeing a problem already off the bat. I don't think I'm going to cancel something. There is a way we can get around that, though. Let me show you how. U is equal to X plus 1. Therefore, du is equal to dx. This one pops out pretty nicely. So this is going to be the integral. Let's move this 2 out front to begin with. That way I don't have to deal with any unnecessary constants.
Or distribute.
Yeah, I could if you wanted to. It's up to you. Whatever you think is easiest. U squared times du. And this is what Macy was noticing. That x up top isn't going to cancel. But, in a way, I have made my life a little bit easier. Look at the denominator. I've turned the denominator into something that was complex into something that's not complex. So I'm thinking if I could just get rid of that x that's up top, I have a singular term on bottom. And that's when I can actually divide things. If I had x plus 1, I can't divide everything on top by an x and a plus 1. That's not good. What I mean by that in your head, let me flip to the side. This is good. This is bad. Because this I can divide this here and this here. I cannot do that here because I have a complex polynomial on bottom. So I have turned something that had 2 terms down on bottom, and actually 3 terms because it was a trinomial because it's squared, into something that is just a singular term. So, any ideas? I want to get rid of this x if I can.
Plug in x plus 1 and do it that way.
Yeah. Up here, I created an equation that relates u to x. Let me just rearrange that. If I want x in terms of u, that means I want x all by itself. Let me move over this positive 1. So I get the relationship that says x is equal to u minus 1. So in essence, I'm using my u-sub. I'm just using it twice in 2 different places. I'm using the u that I replaced originally. Let me rearrange it again, and I'm going to reevaluate my u-sub. So I'm going to do it again, and I get this to the integral of u plus 1, or sorry, u minus 1, all divided by u squared du. Now that, even though it looks a little bit more complex, is something that I can mathematically manipulate so that it is just term by term. U squared, or sorry, u divided by u squared gets me what? 1 over u. So 1 over u minus 1 over u squared. Well, that's just u 1 over u squared. Alright. Integral of 1 over u is what? Natural log.
Oh.
Oh, I was right. That's a first.
Don't forget there's a big old 2 out in front of this. 1 over u squared. This is u to the negative 2 power. So I can use my reverse power rule. This is going to be minus u to the negative 1, all divided by negative 1. Plus leave the end. Let me clean this up. Negative divided by negative, that's going to turn that into a positive. So this is 2, all up front, so I need parentheses. ln of x plus 1 plus 1 over u, so 1 x plus 1 plus c at the end.